a nice opportunity to speak in this beautiful new room. That's fantastic. Michal, you organized that well. So, I'm going to do the wrong thing. I'm going to give you a presentation and I demo something. And lesson number 1 is never do a demo during an important presentation, right? So I'm going to do that. So, I hope I get things running because I have to type, and with this microphone it's a bit difficult. Do we have a kind of other microphone? Is it this one?
I think it's the only one we have.
Okay. If you don't hear me, shout, okay? Then I will make it work. Okay, that worked. Fantastic. So let's see if this works as well. Yes, there we are. So, I'm going to tell a little bit about QuickCheck and EUnit and how things can be combined. And this is a kind of a fun project we did together with Simon Thompson, one of the authors of the Erlang book. You probably know, he's a professor at Kent University. My name is Thomas Haks and I work at QuickCheck. I used to be professor at Chalmers as well, but I quit that job in January because this was much more fun. So that's the reason I'm full-time now doing QuickCheck stuff. And Pablo Lamela is one of my master students of that time, which helped me implementing this part of the QuickCheck extension. So, what is this all about? Developers, they do write unit tests, right? So that's what we teach, and that's what practice is, write unit tests. And every developer knows that you never write enough unit tests because you have no time. Somehow management thinks that it's very important to deliver software quality, but they never give you time to write tests. So you write a few tests. And the question is, how can we help people to write a few more tests? And the idea is, of course, to use QuickCheck. And if you haven't heard about QuickCheck, then I'm not going to tell you much more about it, but I will show you a little bit. So QuickCheck is a tool which generates tests automatically for you. Of course, you need to give it some input as well. You normally have to write a model. You have to write a model, and then from that model you get your test for free. Or you write properties if you like. And I find that very simple and engaging, and I like writing properties, but some people have a bit of a trouble writing them because it's a shift of mindset, you have to think a little bit different. So it's a bit hard. So what we did instead was then to let people write tests. Let you write a few unit tests. And then use machine learning to learn from those tests what probably the model behind it is. Create a model, use QuickCheck to generate more tests, show them to the actual developer and say, hey, wouldn't you test this as well? Is that a good test? Yes, and then you test that as well. So that's the whole story. So you use the test, you learn from the test, we use a learning algorithm for that. You visualize the information so that even if you don't run tests, you can at least see what's happening, and then you automatically propose a new test and say, hey, shouldn't you test this? So if you want to read all the details on how this is done, on which algorithms and all that stuff, read the publications in the Erlang workshop, the ACM proceedings, either 2010 or the follow-up paper in 2011, and you will see how it works. Okay, what I do now is to show you an example, because I don't like to show you the algorithms we use and all the complex stuff. I just want to show you how does this feel in practice, so that you can get a feeling, would this be something for me as well. So as an example, we take a frequency server. It's a very simple Erlang program. And even though it's simple, it needs some testing, right? And the idea is that the server has a number of radio frequencies, and the mobile phones, they can talk to that server. And they claim a frequency to talk, and then when the call is done, they release the frequency, and that's it. So that kind of systems is typically a system you would implement in Erlang, and of course, that's what we do here. And we took this example from the book from Simon Thompson and Francesco Cesarini, and I will just show you how you could write tests for that. Okay. So this system is a state-based system, right? So there is of course some state. You have some frequencies that you have reserved, and they are taken, and others are free, and you ask for one and you get something else. Now let's concentrate first and for all on the most stupid thing you could do, starting and stopping the server. So somehow you have to be able to do that. So I'm now the software developer here, and I want to write a test case to start and to stop the server. Yeah? Now, I'm a very advanced programmer. I first look at the specification, right, before I start writing tests, and I see the specification, says, okay, it has 4 functions, a start function, a stop function, an allocate and a deallocate. I look at the start and the stop function, and the start function takes a list of integers as input, and it returns true, and the stop function always returns okay. Fine. And I know the implicit meaning of that. So I write my first test. So this is my first test. It's written in EUnit. EUnit is a nice framework for writing tests, so I wrote it in EUnit. You can also write it in the kind of manual style, but EUnit is nicer because it is a kind of framework to do it. So it has some conventions that you can follow. This is an Erlang function. Who of you has seen Erlang functions before? Is this your first introduction to Erlang? Have you seen Erlang before? Excellent. So this is an Erlang function, and this strange macro, this question mark, assert match, that's EUnit telling that the left hand side should be equal to the right hand side. So it's pattern matching. And it raises an exception if it doesn't match. So basically what we say, we can start the server without any elements, right? With an empty list of frequencies. This is a border case. Unit testing people like to test the border cases. This is a border case, test that. And then we also test another border case where we have one element, one frequency that you can allocate. In between we have to stop the server. You can't start the server, stop it, and start it. Start it and start it again with new one. You have to stop it in between, and we also like to clean up after that we are done. So we clean it up at the end. So this is our first test. Beautiful test. I can't think of any other test than probably putting some more frequencies in the list. Right? But then we really have tested this, haven't we? Okay. So, what is then, you could wonder, the simplest model that this test represents? So what are we actually testing? Can we, from the test case, learn something? Can we see what model are we actually testing? And the answer, you don't have to know that, but we will see that very soon. So what I want to do now, if I get the thing running, is to demo this by running this test. There's only one test at the moment. So I run this test, and then I visualize the model that my machine learning program got out of that. Yeah? So that's what I'm going to try to do. That might actually work. Okay, get out of this one. Make sure I have the mirroring on. Yep, I have mirror display, so that's fine. Then I see the same thing as you see. That's good. So, let's run the tests. I prepared this all very well. So what it's doing is it runs the EUnit test. After running the EUnit test, it starts that machine learning program, learning from the output of the test, because we keep the trace of the test. From that learning, we make a picture. That's done in 3 steps in this demo, to minimize the risk. The test passed. Fantastic. And then I started up this picture, and I hope it's big enough. I can't really make it much bigger, but here we are. The minimum model that I have here is we start in an initial state, and we can either do a stop or a start. Fantastic. That's all there is in that test case. We can either do a stop or a start in the initial state. Some of you will already think, well, that's a bit weird, isn't it? That we can do this. What we can do now is to tell QuickCheck, well, given this model, what kind of test cases would you be able to generate for us? So we start QuickCheck with the model. And this model that I'm using now is the newest model I've just compiled. So while I was making this model, I was also compiling it, and this is the newest one. I can show you later on that indeed this is not prearranged, but I'm making this code on the fly and I compile it on the fly, and I have my model. So let's run QuickCheck. Bang! After 2 tests, it fails. And what you can see here is that you get a long test case here, right? This is the failing test case. This is what QuickCheck tried. Given this model, it says I can do start, I can stop the server, I can start it again, I can stop it, start it, stop it, start. That's valid in my model. The model had only one state, initial state, and it can do all this stuff. So I propose this new test case, it says. I propose this test case as a test case that you haven't tried. But that's a rather big test case, right? And it doesn't really make it easy to understand why you would add that test case. But then, QuickCheck is smart enough to start some shrinking. It says, well, I can probably do something smaller. What about this one then? I start in the empty state and I just stop the server. Shouldn't that be an error? Because I do get an error back. Yeah? If I stop my server without starting it, I get an error back. So shouldn't you test that you actually get that error back? Is that the correct behavior? And you think about it and say, yeah, that's correct. You can't stop something which hasn't been started. So you actually say, that's a good test case. So you go to your tests, and these were the tests I was running. I had a start-stop test there, and that's exactly the one I run. And then I'm going to add the new test, and in order to, again, minimize the risk, I take the one that I have here and I uncomment that. Oops. And I have to do it correctly. So here we are. This is, I get an error if I only stop. That's the test case I wanted to add. That's okay, I will do that. And then I start a demo again. I rerun all my tests, and that's now 2 tests, and hopefully they pass. And if they pass, I will see another figure here than the one I had before. So there we go. 2 tests passed. So machine learning and says, you mean that you're actually making this system. The system where you start in initial state, then you can either do a stop and you come into an error state, right? That's this one, you get into an error state. Or you start, and then you get in a state, and I have no clue, but apparently you can do stop and start in that state however you want. Right? That's my next model. So I've added a test case, I learned from that, I get a new model. Fine. What I'm going to do now is to say, well, that's fantastic, but run a few more tests that you automatically generate. So I start QuickCheck, the new QuickCheck for this new model, and it starts to say, wait a minute, now I get this test. So don't look at the top, this is a bit boring, but look at this one. It says, actually, in the empty state, I can actually stop the server. And that's okay, it's not an error, it's a match. Weird. Why is that? So let's run another few tests. It says, in the empty state, I cannot do start, I get an error back. That's weird, isn't it? So why is that? That's because I run a lot of tests. And those tests are completely random. And sometimes I simply forget to clean up. My model hasn't said anything about cleaning up. There was no cleanup code in that model. So I don't clean up after my test. The test ends up in a state where it has been started. The next test state comes in, and okay, the stop works, or the start fails. That's not really nice. So my model is not good enough. I forget the cleanup code. So now I can do 2 things. Either I think of some cleanup code that I want to add and do that in my tests, and we'll do that in a second. Or I can go, if I'm a bit more advanced QuickCheck user, I can go and look into the QuickCheck code and look where the cleanup is, and then I add this stopping. And I prefer to do the second one just for the sake of it at the moment. So, I had a window open here where we have all the code, and here we have this frequency EQC, which is today created 2 minutes ago, and that's the one that I actually built. Here's the code. So this is the model that I got from the picture that you saw, and from the test cases run, and here we have some cleanup code, but the cleanup is actually doing nothing. Right? So I would rather stop the server there, just for the sake of it. So we stop the server in the cleanup code, and then we recompile this code, done, and now I just run QuickCheck. And now I get another error. Right? So I get an error saying that, okay, the first thing you do is you start the frequency, that's okay, you match it through, and the next one is that you get an error. You can't start the server when you have started it before. And then the question is, okay, that's not, we shouldn't be able to do that, so I'm going to add this test as well. I can copy this test case and put it into my suite, or I can do something slightly more advanced. I can use EUnit, which has a kind of a closure where you can do both a setup of something and then running some code and then do a stop. So it's a special data structure describing that first you do this, Then you run whatever you have here, and then in the end you clean up by using this code. Yeah, that's in most unit test frameworks have that kind of structure where you can explain what to do in which order and how to clean up. Fine. So this is kind of an error case that I add. So let me see what happens there. I will have to demo. Oh, I didn't save it. I think no, I didn't. So let's do that. I save this, and then I run 3 tests now. I pass all the tests, and this is my model. It looks much better, doesn't it? Even by the eyesight, you can see that this is indeed what you want to do. You want to do, if you start a server, then you go to a state number 1 here, and then you can stop it, and then of course an initial state again. Or you try to start it again, and then you get to the error state. And if in the starting state you go and stop it, you end up in the error state as well. Much nicer. So do we have enough tests now, or is there anything else we can test? Well, from the model we would say, well, this is about it, right? We can't do much more, but let's just, to be sure, test this a bit more. Ah, right. And then let's have a look at the code that I changed just before. So this was the code I had, but let's reopen that one, because I changed it on disk. Let me see, revert buffer, there we are. I want to read the new code. And as you can see, I added something actually in the cleanup code, because I understood this EUnit test. I understand there's a setup and there's a teardown, and the teardown is cleanup code. So let's take that cleanup code. So I added that already in my model, because it is in the test cases. Okay? So no worries there, this will work. I pass 100 tests, and another 100 tests, and another 100 tests. So this really works. So that's the idea. Go back to my slides for a second. Okay, so what I did show was that you run the test, you visualize the model, you try to, from the simplest model that you get, to understand, is this correct? Is this indeed the kind of behavior that I expect? You could already see from the picture that, well, probably I'm missing something. But instead of thinking hard and think, what test case should I actually add here? You just let QuickCheck give you a test case which makes sense in that context. So QuickCheck makes automatic tests from a specification, and that specification is the kind of thing you saw in the second text form. We create that model by using machine learning while we're running the tests. So we run, the second demo was running QuickCheck. I was a little bit ahead of myself. We got this other model here where we say, well, look, we have one error to the error state, and in the state number 1 we can still do a lot, but we add one more test case. We run QuickCheck again, and again we find a new error case, and we add this kind of closure to the tests, and then we run QuickCheck and we find 100 test cases which just pass. Okay, so this is then the final model that we have with that test case. That was a little repetition. So what we do here is we actually get the tests for free, right? We build new tests from existing test suites, and we do that by enriching actually the specification. The tests are only a part of the specification. You can get far more information from those tests, and with that information we can start varying. We can vary the list of frequencies. We can vary the sequence that we run. We can do that automatically. So I want to go back to my demo now and show you what happens if we start allocating resources, because that's of course something you really also want to test. With this. Okay, where were we? Here we are. So what tests shall we add for an allocation of a frequency? We need to, at least, this QuickCheck can't do. It can't kind of make up a test case for you completely from the command. So we have to give one test case. Let's take a very simple one. What do we have here? This looks pretty much okay to me. So what we do is we do a setup where we start with one frequency and then we allocate it, and that should be okay. And we should get one as the allocated frequency because we have only one in there, and then we should stop. Okay? That we could do. Now we have 4 tests, and this is what's happening as a picture. Right? So we can do a start and a stop. And if we are here, then we can actually allocate. That's exactly what we expected. But do we have enough tests? That's the question. Okay, we can allocate here, but does that really work? So we want to see that by running more tests and say, is there a failing case? And the failing case it comes up with is say, well look, your tests don't really test that if I start a server with an empty set of, an empty set here of frequencies, that if I then do an allocate, I actually get a bad match because there are no frequencies available. Yeah? It can tell you that this is a test case you have never tested. Okay, let's add that test case. If it is not already in here, I will just copy and paste it in there. This is much more advanced stuff. So let's take that test case and copy it here somehow. Copy, paste. So what shall we call it? We say allocate 0 or something like that. You cannot allocate a 0. I'll save this. I run the demo again. Oops, this test case failed actually. So I have made a mistake. Oh yes, I used stop there. No? This is the demo thing, you know. Don't do it. I used the frequency in front of it. I think that's the problem in this case. So it should not make any difference. But apparently. Or I have something else happening here. Unexpected success. Okay. Okay. Well. Let's try once more. No, I don't really seem to get it working. So I will remove that and jump back to the. That's bad. But there's always kind of small things that can happen. So I could better look for how I write the test case here. Okay. I forgot to stop. Yes. I forgot the closure where I should say, okay, you have to clean up after this test. Yeah. So this is what's actually. You start the test here, you do this frequency allocation, but you have to tell it to stop after that test, because otherwise, of course, it goes wrong. Okay, fine. You have to clean up in your test case, otherwise EUnit will fail. All 5 tests passed, and now I get my picture here. So, you start, you can go to state 1, you can allocate, and then you get to the error state, or else you go to state 2, where you can allocate as many times as you like, or you can stop as many times as you like. So this is still a bit of a crappy model, but it's better than before, because I can't allocate infinitely often here when I start with the empty list. So here you actually see that I start with the empty list and I start with 1. Those are 2 different cases. One gives you 1 allocation and you get to the error case, and here you can still allocate as much as you like. So then again, you can, and this is the last time I show this, you can create a new one, new test case which says, well look, you didn't test this one. If you start with 1 element and then you stop, and you try to allocate, what happens then? Shouldn't you put that test case as well? You can't allocate after stopping. And then you add those test cases, and in the end you get a very nice picture here of a model where you can allocate as many resources as you have, and then you know, that picture looks nice, and you pass 100 tests. This is well-tested software, and there you are. Okay? So this is how we can help people to write better test cases. And then, of course, my hope is that if if you see the model, the QuickCheck model, if you look at that, and you look at the picture, you would say, well, that's actually not so difficult. Next time I just write the model straight off from the start. But it helps you in learning how to write proper unit tests and what kind of tests you really want to put in the model. So, implementation, how do we do this? Well, first of all, we instrument EUnit to actually create a trace of what it has been doing. So you actually trace through the code. Every API call you do, you keep in mind. Then you add a number of assertions to that trace, in particular following the return values, and you have to connect that to the input values and all that stuff. So you make a rather enriched trace. Then we use the blue fringe learning algorithm. Blue fringe is one of those algorithms which is very good in learning if you have both positive and negative tests. And that's exactly what we need here. So we have experimented with a number of machine learning algorithms, and we just found this the best one to serve this purpose. So we run that over this long trace, and we get some information from it, giving us the picture. And then the picture, together with the actual traces, give enough information to make a QuickCheck model which is richer than the picture, because we have the data in there as well, but it has the same structure as the data. So we make that QuickCheck model, we compute that on the fly, we compile it, and if it doesn't compile, we will complain about it. It normally compiles because it's automatically generated. Then we run the QuickCheck property on a variation of calls that you can make. There we do the randomization, we randomize the input, we randomize the number of calls according to the model given, what the model allows, and then we get a new test. We add the test case to the test suite and we start working. So that's the whole procedure. Okay, and to conclude my talk, the main purpose of this is to make fun out of testing. So writing EUnit tests gets a lot of fun with this kind of methodology. Thank you very much.
So I assume that this learning part from EUnit test is a new thing, yes? Because I haven't heard about it.
No, this is new. This is, well, new was in 2010 we started this, but this is kind of a hobby project. So we did this.
Because the writing the model itself from the scratch in the QuickCheck language was kind of hard.
Yeah, that you need to learn something. Yeah.
This is
so now we let the computer learn. Right?
This one looks.
This is it's kind of powerful, so because you only have to write a few tests, and bang, you get the rest for free. But you still have to have control. You learn which test case do you actually want to add to your test suite. So, yeah.
It looks really powerful.
Happen that the learning algorithm, this blue fringe, fails and creates some weird situations?
Blue fringe, yeah, that's a good question. So the question was, does it happen that blue fringe doesn't give a nice learning outcome, a nice state machine as output? And of course that happens. Blue fringe is one of those algorithms, and EFL algorithm has some other weak spots. So in blue fringe, it's extremely important that you have at least one negative test case, because it learns from positive and negative. So if you have only positive test cases, then you get always one state and lots of errors. So when we did this, we looked for an example of EUnit test in GitHub. So let's look in GitHub, and we do that instead of our own example, we use GitHub. So we looked at all the GitHub repositories which had EUnit directories or had EUnit in the text somewhere. We found plenty of them. We looked at the EUnit directory and really excited, and top empty, you know. That's how people really like to write those unit tests. So, and then we found a few which had a few test cases there, but they were all positive test cases. There were no negative test cases. So we asked in industry, and we went to Ericsson, and said, don't you have some kind of test suites with lots of test cases in EUnit? And Ericsson said, well, we mostly use common tests, but we had a guy in Linköping, and he had written something. He had 10,000 lines of EUnit tests. Yes, you know, let's try it. No negative test at all. So, and then it gets a bit hairy because you get so many state changes. But so the answer is yes, you get some very strange things if you don't get negative tests. But if you have a nice combination of positive and negative, the algorithm is pretty good in giving you a nice model. Yes.
I was wondering what do the But the percentage numbers stand for...
Ah, right. Yeah, so what I did, I was a bit lazy there. I used the normal QuickCheck output for the state machine. So the percentages on the errors were the likelihood that that part was tested. So you test, if you had a very thick error, then most of the tests were in that error. So it contained that
but
transition.
It's like the percentage of tests, the generated tests, or the variation is based on data, or just...
The variation is based on the model you have. So if you have a model,
Okay.
then there is a standard distribution for how tests are generated. And if you use the standard distribution, then this is your test output. And if you want to improve that, and that's a bit too difficult to explain here, but if you want to improve your testing, you want to improve the likelihood that certain transitions are made. You want to test more allocates, or you want to test more allocated. And then you can change that in the model. But of course, that's not something you get from your tests. So you have to add that later on.
Okay.
Okay. Okay. Thank you.
Thank you.